So if you've been training with type 1 diabetes for any length of time, you've probably noticed something a little bit strange. So if you're going for a run, your blood sugar drops. But if you lift weights, your blood sugar climbs. And it's the same body, it's the same day, but you can have two completely different reactions. And most of us just file that away as one of those diabetes things that we can't really explain or don't really understand. But there's a very clear reason for both of them. And once you do understand it, everything changes. So you stop staring at the CGM data mid-session, wondering what's going on, and you start actually knowing what's coming before it even lands on screen. So today I'm going to walk you through exactly what's happening inside your body during each one, and I'll give you a plan for both. So let's start with cardio. When you do sustained aerobic work, so this is running, cycling, swimming, rowing, your muscles need a continuous supply of glucose. And here's the thing that actually changes everything for you as a type 1. So they get it through a pathway that completely bypasses insulin. And here's how it works. So inside your muscle cells, there are proteins called GLUT4 transporters, and these are basically glucose doors. So we can think of them that way. At rest, those doors are stored inside the cell where they won't do anything. And to open them at rest, your body needs insulin. Insulin binds to a receptor then on the surface of the cell. This triggers a chain of signals inside it, and then the chain moves the GLUT4 to the doors of the membrane to open up that door so that you can pull glucose from your blood into the muscle. But the thing is, during aerobic exercise, a completely different pathway kicks in. So when your muscles are contracting and working hard, they activate what we call AMPK. So just think of it as a fuel sensor. So when the muscle is burning through energy, AMPK activates and sends those GLUT4 doors directly to the membrane, independent of insulin. So there's no insulin involved, and then the door opens on its own. So what this means for you during cardio is that you've got two separate things pulling glucose from your blood at the same time. You've got the insulin that you have circulating from your last dose, and then you also have the exercise activated GLUT4 pathway running at the same time. And that's why glucose can drop faster during cardio than almost any other situation, because you basically have these two doors or two keys being turned at once. Even when your dose looks right on paper here, the combination of both can still drive your glucose down a lot faster and a lot more than you would expect. So what to take away from this is that GLUT4 pathway doesn't switch off during cardio, and it doesn't care what your dose looks like before. It's activated by the exercise itself, and it stays on for the entire session, which means you have to plan for the drop before you start moving, not after you're already in the session. So you can't react fast enough to what's actually happening here most of the time. So how do we plan for it then? So I want to keep this super simple and go through two scenarios based on how long you're going to be exercising for. So scenario one is under 45 minutes. Your starting point here will want to be between 6.5 and 9 millimoles with a stable or flat arrow on your CGM. And if you're sitting between, say, 5.5 and 7 with a stable arrow, we want to take about 10 to 15 grams of fast-acting carbs, wait about 10 minutes and then start. And if you're below 5.5 and you're seeing any kind of falling arrow at any level, we actually want to think about treating that first, waiting again about 10 to 15 minutes until we get a stable trend, and then starting the session. At this session length, you generally don't need carbs during the session itself once you fuel yourself properly before. For 45 minutes and over, at this duration, we do need to start a little bit higher, typically between about 8 and 10 millimoles with a stable or rising arrow. And at around the 20-minute mark, we can take 15 to 20 grams of fast-acting carbs. And the big thing here is that we don't want to wait until we feel it dropping, because by the time that we feel it, your CGM is already 5 to 10 minutes behind what's actually happening in your blood. So we do want to think about acting on the trend early. So after that first top up, we can take about another 15 to 20 grams of carbs every 30 minutes or so for as long as the session continues. We then want to check your CGM every 20 to 30 minutes throughout. So the principle across both scenarios is the same, that we want to feed the session as we go and not just before we start. So if we put, say, 40 or 50 grams of carbs in before a session, you'll spike early, which then can prompt a correction. And then that correction alongside the mid-session GLUT4 drop, when they happen together, you can crash exactly at the wrong point. So we want to think about small amounts, frequent amounts, during the session. So now we can look at weights, and the mechanism here is completely different from cardio, and the understanding of this being different from cardio is what will help it to make sense compared to what you've seen before. Heavy resistance training puts a significant stress on the body, and your body interprets it in that way, and not as a dangerous threat, but as a real demand that it needs to respond to with fuel. So that response involves your sympathetic nervous system, which triggers the release of what we call catecholamines. These are basically stress and performance hormones, and more specifically, adrenaline and noradrenaline. And once catecholamines are in your bloodstream, they then head to your liver. And what they do there is they tell your liver to release glucose. This happens through two processes. The first is what we call glucogenolysis, and this is basically where your liver breaks down stored glycogen, which is already in your liver, into glucose and puts it into your blood. And the second is a bit of a mouthful. It's what we call gluconeogenesis, and this is basically where your liver actually manufactures new glucose from other materials in your body. So the likes of amino acids, lactate, glycerol from your fat. And both processes are running at the same time. And the result is that we can get a significant and rapid rise in blood glucose during these sessions. So in someone without type 1, the pancreas will detect the glucose rise and it immediately matches that with extra insulin to counter it out. But so the system corrects itself automatically. But for you and me, the automatic correction isn't there. So your glucose just climbs, and on a heavy day with the likes of squats, deadlifts, heavy pressing, you can expect a rise of typically about 2 to 4 millimoles. And on more maximal effort days, it can even go higher than this. So the key thing to understand about weights is this, that the glucose rise is expected and it's temporary, and you shouldn't try to rush and correct it mid-session the first time it happens. And here's why. Because as soon as your session ends and the catecholamines begin to clear and your glucose comes back down to normal, often faster than you'd expect, because your post-session insulin sensitivity is significantly elevated. So your muscles have just depleted their glycogen stores and now they're actively trying to replenish them, which means they're pulling glucose in aggressively. And if you've ever taken a correction mid-session and the correction is not working at the start and then all of a sudden your levels drop off a cliff, this is because after the session, it will start working in a newly sensitized environment that's driving your glucose down hard. So that's where the post-training crash actually comes from, and it's almost entirely preventable once you can understand this. So in practice, here's how to actually approach a resistance training session as a diabetic. So first, the correction rule. We don't want to correct for rises that are under 13 millimoles. The catecholamines will clear and the glucose will come back down on its own. If you are between, say, 13 and 16 and it's starting to level off and you're in, say, the last third of your session, then we can hold on and wait. And if it is climbing or you're early on in your session, then a partial correction of about 25 to 50% of your typical dose is typically appropriate here. If you are above 16, it's best here to actually just pause, take a small correction, again, about 25 to 50% of typical dose, wait about 10 minutes, which you can do some light movements, so incline walking or very, very easy stationary bike to activate that GLUT4 pathway and help bring down the levels faster and help clear some of the catecholamines, and then you can get back in. Second thing here is we actually want to use your warm-up deliberately. So before your first heavy set, we can spend about 5 to 10 minutes on something light. So something like a stationary bike, a slow treadmill walk, maybe a rowing machine at easy effort. And this partially activates your GLUT4 before the catecholamine response from heavy lifting actually kicks in, which will help to give you a slight glucose lowering effect coming into the session, but it also gives you a proper baseline reading and a trend arrow before the heavier work starts, so you know exactly what you're working with before the spike begins. Third, we can actually use breath work here between our heavier sets to reduce the catecholamine response. And here's how we do it. So between your heavier compound lifts, so squats, deadlifts, benches, we can think about in between sets, inhaling through your nose for 4 counts and then exhaling slowly through thinly parsed lips. And this extended exhale basically helps to activate your vagus nerve, which is your body's rest and digest switch. So this helps to lower your heart rate. It also helps your body to clear those catecholamines, so the adrenaline, the cortisol. It'll help to get your heart rate back. And if we can do, say, even as little as 4 to 8 rounds of this in between our sets, it will help us from a diabetic and blood sugar management perspective, but also from a performance and recovery perspective in the session. And beyond that glucose benefit, you'll also find that you'll recover better between sets and you will feel more in control in the heavier work. The fourth thing here is we want to think about extending the rest periods on heavier days as type 1 diabetic. So shorter rest periods of 60 to 90 seconds, they can work, but they keep cortisol and adrenaline elevated throughout the session, especially on those bigger days. The reason being is there's just not enough time for them to actually clear those catecholamines. And on heavier compound days, if we can think about resting 2 to 3 minutes between sets, Combined with the breath work, this actually allows those catecholamines to partially clear between effort, between your sets, which then moderates the glucose spike across the whole session. So you'll have better management and better performance. And fifth thing, and this one is if you have a little bit more data stored up from your sessions, but after say 2-3 weeks of training, if you're consistently seeing a significant spike on a heavier day, then you can actually think about increasing the bolus of the pre-workout meal by 10 to 15%, which will basically create a slight buffer under where you typically sit coming into the session so that you are accounting for the spike. Apart from this, you can experiment with intra-workout insulin. This is something that I would be quite careful with. Typically, the best times to do it in a strength session are going to be when you actually start the session. You take your insulin dosage, you do your low intensity cardiovascular work to warm up. So say, for example, you take your insulin, you have 10 minutes on the treadmill. Then when the insulin actually just about starts to kick in, you're starting your heavier sets. Your catecholamines are through the roof, so you're getting that rise, and the insulin is acting to counteract that. But the big thing here is that once you have this understanding, you're going to be able to apply these principles to your individual circumstance. And that is what is really necessary here, is everyone is going to have a slightly different approach that will work best for them. So in order to actually action this, we have 2 separate tasks for this week. So after your next cardio session, I want you to write down the duration of the work that you did, your starting glucose, and then your glucose every 20 to 25 minutes. And then after your next weight session, I want you to write down your starting glucose, your glucose at the halfway point, and then your glucose 30 minutes after finishing as well. We don't want to change anything just yet. Think about just collecting data for the start, because again, you can't build a reliable approach without knowing your numbers, without knowing your individual data first. So there we have it, 2 completely different physiological mechanisms, 2 completely different approaches. Cardio is about anticipating the drop and then fueling ahead of it, and weights is about actually letting the glucose rise, not necessarily fighting it, and protecting yourself from that post-session crash. Once you understand what's actually driving each of these responses, you can stop guessing and start managing it with intention, and that is the foundation from which everything else can be built on.